module which has three parts, which is your arbitrage, then your replication, and your cost of carry, or which is the cost and benefits associated with an underlying asset. We will cover the first one, which is the introduction and arbitrage, in the first video. We will cover replication in the second video, and we will cover cost and benefits associated with owning the underlying asset in the third video. So again, this learning module will cover arbitrage and replication as used in pricing derivatives, and how the costs or benefits associated with owning the underlying asset affect the forward commitment price. So let's get started with arbitrage. Now, what is arbitrage? Arbitrage is basically being able to make a risk-free profit. You will only be able to do that if the law of one price is violated. If the law of one price is not violated, then you cannot have an arbitrage profit. However, if it is violated, which means the law of one price does not hold, then you will be able to make an arbitrage profit. And now let me explain to you what that means. One situation can be that you have two assets and these are identical in the sense that the cash flows that they are offering you are identical, but they are trading at different prices. Now, how this is possible? Let's say you have two bonds and they are identical, which means that the amount of coupon payments that they are giving you in terms of the cash flow is the same, right? The face value they will give you at maturity is the same, but they are trading at different prices. So that doesn't make sense, right? I mean, two assets which are giving you the same coupon payments, which are giving you the same face value at maturity, why are they trading at different prices? Naturally, what we should do is buy the cheaper one and short sell the expensive one, and I will demonstrate how exactly that will play out. But let me just make your mental foundation here that in one of the situations where the law of one price is violated, where it does not hold, is that if two assets with identical future cash flows are trading at different prices. If that happens, arbitrage profit can be made, and this should not be possible, right? This is just something unnatural. The second situation is that one asset with a known future price. So let's say we are talking about gold, and in the future, let's say 1 year into the future, you can buy 1 ounce of gold for, let's say, $1,792, right? And it is available right now for, let's say, $1,777. And even if I buy this right now, right, and I take it into the future, and even if I buy it based on a loan, so I borrow and buy, right? So even after I add my interest, let's say I paid 1% interest on this or whatever, right? And this becomes worth, or let's say I pay $10 interest on it, so my cost becomes 1787. It is still less than the future price. So these two prices should be the same, which means the future price of the derivative, which is the price of the asset available in the future, should be the same as borrowing the funds and buying the asset now. If there is a difference in these two prices, that is, the known future price is not equal to the present value of its future price, right? So if you take this future price and bring it back to the present value, if it is not the same as the spot price, then that means there is some arbitrage possibility. And I will take you through detailed examples for both of these scenarios so that you clearly understand what we are talking about. So let's start with the first one, which is scenario 1. And there are two bonds, two zero coupon bonds, A and B, and they are having identical features. They are exactly the same, right? But one is trading at 99 euros and the other one is trading at 99.15 euros. So this 0.15 cents extra is unnatural, right? I mean, if they are both identical, then why one is trading a little bit extra price? So what we will do, we will sell this expensive one and we will buy this cheaper one. Now you might be asking, how can you sell this expensive one when you don't even have it? So naturally we're not going to sell it, we're going to short sell it, which means we will borrow it and then sell it, right? So that is what is happening over here, that since bond A is cheaper than bond B, because bond A is for 99 and bond B is for 99.5, so we're going to short sell bond B and we're going to buy bond A with the money we will get from short selling bond B. And what does that mean? It means we will borrow bond B from the market and we will sell it for the market price, which is 99.15, and then we will use that 99.15 to buy bond A for 99, and we will pocket the 0.15, right? And in future what we will do is we will then sell bond A, which we had bought for 99, we will sell it for 100, because both of them will reach the price of 100, and we will use that 100 to buy the bond B and then return it to the person we borrowed it from. So our transaction is finished, but in the meantime what we did was we pocketed this 0.15 extra, and this is basically your arbitrage profit, which is risk free, right? And this slide actually demonstrates this exact transaction, that first what you do is you borrow bond B and you sell it and you receive cash of 99.15. You use that cash to borrow bond A, to buy bond A, and this additional cash you put it in your pocket, right? This is your profit, risk-free profit. Then what you do is at maturity you sell the bond A, which you had bought for 99, you sell it for 100 and you use that 100 to buy bond B and cover the position, which means return it to the person you borrowed B from in the first place, and you have your profit still with you, right? Now obviously if this scenario will be there, then everybody is going to rush to make this free profit, which means they will all want to borrow and short sell bond B and buy bond A with that money, right? Which means they will want to sell bond B, driving its price down. They will buy bond A, driving its price up. And eventually both of them, bond A and bond B, will come to the same price, and therefore arbitrage will not be possible. And this is an important condition which must hold for derivative pricing. Now let's look at the second scenario, where we were talking about the gold price being different in the future compared to what it would be based on its existing spot price and adding the time value of money. Now adding the time value of money can be done in two ways. It is either discrete compounding or continuous compounding, and this ties in with what you have learned in your quantitative methods, right? Where you take the present value and you multiply it with 1 plus r to the power n if you are doing discrete compounding, or if you are doing continuous compounding, then the present value is multiplied with e to the power rt for continuous compounding. So now for majority of the cases we are going to be using discrete compounding, where we're talking about an asset like stocks or bonds, then we'll be using discrete. But for portfolios like an index of stocks or something like this, then we will be using the continuous compounding method. So the continuous compounding method is usually used for a portfolio, example an equity index, right? Whereas the discrete compounding is usually used for individual underlying assets like stocks or bonds. Now let's look at an example so that this becomes very clear to you. Now a company has the opportunity to buy 100 ounces of gold at an agreed price of 1792.13 per ounce in 3 months. Now this is in the future. The future price is 1792.13 per ounce of gold, and the spot price today is 1770, right? and the interest rate is 2%, but this is for the whole year, and we are talking about 3 months over here. So this is the future price after 3 months. Now, can the company generate a risk-less profit? So what we do is, let's say if we borrow the money today, this amount, and we pay interest on it for 3 months, then how much will it cost us to have this 1 ounce of gold? So let's look at the answer here. Let me just erase this part for you. Okay, so as you can see, what's happening over here is that we did borrow the money and we bought the gold with it, right? So we bought it at the spot price of 1770, and at 2% we paid interest. So what that becomes is 1778.78. How did we reach to this number? It is basically your original borrowed amount, which was 1770, right, multiplied by, this is your spot zero, basically the spot price that you paid, multiplied by 1 plus R, and R is your 2%, so 0.02, and you did it for how many months? 3 months. So what we will do is we will say 3 over 12, and when you multiply this, what you get is 1778. So what has happened is that you borrowed how much money? 1770, and you paid interest of approximately 8.88 actually, and what this 1 ounce of gold has cost you is 1778.78, and in the future market it has been selling at 1792. So if instead of buying in the future market, you sell in the future market, you buy in the cash market today with borrowed money, and you sell in the future market, so you are actually able to pocket some profit because you're selling at this price of 1792. It's costing you 1778.78. So you're actually able to make some arbitrage free profit, risk-free profit, which is arbitrage profit, right? So you can make arbitrage profit because the future price is not exactly the same as the price of the spot plus the interest rate. And this is exactly what you see happening. And since it's for 100 ounces, so that's why you can see they've added 2 zeros to the entire amount. So the company borrows not for 1 ounce but for 100 ounce and pays the interest, annualized interest of 2%. And instead of buying in the future, they sell in the future because the price is high, and obviously we want to sell high and buy low. So what does the cost come to? The cost comes to 1778.78. Why? Because this is how much we borrowed, this is how much interest we paid, and this 0.25 is basically 3 months over 12 months. That's where this 0.25 is coming from. This 0.25 that you see, it is 3 divided by 12, and it is to the power. Actually, this is not like this. This is 0.25 to the power. So you took the spot price, which is 177,000, multiplied by 1 plus R, which is 1 plus 0.02, which is the interest rate, to the power of T, which is 3 over 12, which is 0.25. So this is how you got the cost. This is what this 1 ounce, this 100 ounces of gold is going to cost you. And you have sold it for 179,213. So you sold it for 179,213. It cost you 177,878, and you pocketed this beautiful $1,334.56 risk-free profit or arbitrage profit. So I hope this concept is clear. We're going to look at replication in the next video. But before that, let's just look at the example again in terms of the present value of the known price has to be equal, otherwise the arbitrage opportunity will be there, right? So this is the same concept which is being emphasized again, that since the present value of the future price is not equal to the spot price, therefore there is an opportunity of arbitrage. However, if it was equal, then there would be no opportunity. So how this will finish is basically market participants, they will start purchasing gold in the spot market and they will start selling in the forward market, and slowly the spot price will go up and the forward price will come down, and this difference will be eliminated. So what is the summary here for the entire discussion on arbitrage? That number one, if you have identical assets trading at different prices, then you will have an arbitrage opportunity. They must trade at the same price. Identical assets with identical cash flows must trade at the same price. Otherwise, there will be a arbitrage opportunity. And the same asset, the future price should be equal to the spot price plus the time value of money, or the spot price should be equal to the present value of the future price. So you can either take the future price, you can bring it back, so the present value should be equal to the spot price. The present value should be equal to the spot price, and if that is not the case, then there will be an arbitrage opportunity. And of course, it depends on the time, right? So the longer the time period, the more the future price will be, because of course the interest has to be paid for that much amount of time. So if we're talking about gold, and if we were talking about, let's say, 3 months, then the future price was somewhere around 1790, right? If the spot price is 1770. But if we're talking about the whole year, then naturally it will be higher, because more time means more interest cost. And higher the interest rate and higher the time period, so the higher the risk-free rate and the higher the time period, the higher the forward price will be. And for a given risk-free rate, if you don't change the risk-free rate and if you only increase the time, still the forward price should be going up. So that is it for arbitrage. We're going to look at replication in the next video.